look into another example of widespread pollution, and in that case that would be arsenic. So you're taking Bangladesh case here, but you can take it for most deltas. You have this similar situation. So in here what you're seeing, each of these dots represents one of these tube 1 and palm oils. These are their water infrastructure. So and in here, hotter the color, they are higher the concentration, cooler the color, so the safer the well is. So you can see there is a regional trend. So if you are in the northern part of the country, it's most likely safe. If you're coming in the southern part of the country, it's polluted. And they are very heterogeneous. If you try to touch them by hand, two wells like these two, you can touch them. One will be polluted, the other one is not. So what is the reason? So when it becomes very complicated to think, but if you plot this data vertically, then you can see this is a deep tube well, it's tapping water from the deeper depth, and this is a shallow tube well, it's tapping water from the shallow part of the system, and most of the arsenic is associated with the shallower part of the system in here. So you might be wondering, where is this arsenic coming from? It's coming from the sediments basically. If you have 3 milligram per kilogram of arsenic, if you allow 1% of that to be dissolved, that would give you around 100 ppb arsenic in the well water, which is 10 times higher than the World Health Organization guideline value. And if you think what is the concentration in the sediments, how high it is, but you know that in the UK, in many parts of the country in soil, we have around up to 40 milligram per kilogram of arsenic. So, but we don't hear much about arsenic problem in the UK. What is the reason? So what is the mobilization mechanism? It's basically going back to these microbes again. So within this aquifer, particularly as you come in the southern part of the country, so you have organic matter coming from the surface or from within the aquifer, which is working as an electron donor. And within the aquifer, you do not have oxygen because these are anoxic aquifer. So if it is an anoxic aquifer, if some nitrate comes up, nitrogen will be used up. So there is not much nitrogen as well, nitrate as well within this aquifer. So bugs using these organic matter as electron donor, and within these sediments you have these iron oxyhydroxides where arsenic is sitting on top of them. So bugs are using this iron oxyhydroxide as electron acceptor. As they're using these electron acceptors, these dissolve, and this dissolution leads to this iron and arsenic coming to solution, and therefore you have this problem. So you can see this redox sequence. If you see oxygen, if you have it, then you could have problem with nitrate. So if you do not have oxygen, if you do not have nitrate, but you have supply of organic matter which can provide electron, then you could have a problem with ion dissolution. And that ion dissolution is in this case it have arsenic, ion could have other metals as well on top of them, and that could come into solution as well. So arsenic pollution is down to this ion reduction. So these are the two case study we briefly looked at. So you can see they are both groundwater pollution problem, and we can easily explain them with microbial mediated redox processes.